Hello, my name is Sana Hafiz and this is Lab 2, Lines of Charge. This lab is related to my previous video in that we're still looking at how excess charge builds up on everyday objects. I will discuss the fundamental properties present and experiments to determine the charge of the tapes, as well as computer models to depict the forces present. Electric charge is the physical property of matter. It experiences a force when placed in an electromagnetic field. There are positive charges and negative charges, and charges of the same type will repel each other, while different types of charges will attract each other. The equation to calculate an electric field is 1 over 4 pi epsilon naught times Q1 times Q2 divided by magnitude of r squared times r hat. And the equation to calculate an electric field is 1 over 4 pi epsilon naught times Q1 over magnitude of r squared times r hat. Another principle is the gravitational force and Newton's second law with how the forces interact with each other. This lab is a continuation of my previous video determining excess charge, but instead of looking at the experiment as a point model, we will be treating the tape as a line of charge to estimate the amount of charge on each tape. To determine the amount of excess charge necessary to make the tape float, we conduct an experiment using two pieces of charged tape. Before tape A is introduced, tape B is being pulled down from the gravitational force. After tape A is introduced, tape B begins to float because of the electric force. Now, from Newton's second law, since the momentum of tape B isn't changing, the net force is zero. So that means the magnitude of the gravitational force and the electric force must be equal to each other. To determine a force of gravity on tape B, I need to know its mass. Setting equal to the electric force, I also need to find the distance between tapes when the forces are equal. This will let me solve for the charge of the tape, which I can then divide by the charge for an electron to find the number of excess electrons. And this is the data I collected from my experiment. The length of the tape B was 0.2 meters, and the distance between tape B and tape A was 0.02 meters. This meant that the magnitudes of both my gravitational and electric force were 1.96 times 10 to the negative 3 newtons. In my last experiment, I created a computational model simulating electric and gravitational forces to calculate an estimated charge. You can see how my electric force and gravitational force were acting in equal and opposite directions on tape B. Through my model, I was able to find the magnitude of excess charge to be 9.56 times 10 to the negative 9. While this approach is fine, we can get a more accurate response by distributing the charge over a line. Now we treat the tapes like uniformly charged rods, so we treat the model as a line of charge. To calculate a line of charge, we divide the tape into many small pieces. We find the electrical force that one piece of the bottom tape generates on every piece of top tape and sum those forces together. We repeat this step for every piece of the bottom tape, and the net electric force will be the sum of the electric force generated by each piece of tape. In the point charge scenario, the electric force from the bottom tape on the top tape pointed exactly upwards, so all of the electric force was used to cancel the gravitational force. But with the line of charge model, the electrical force has both vertical and horizontal components, since some pieces of tape will be at angles away from each other. The horizontal components cancel out, so only the vertical components will counteract the gravitational force. So we need more charge to generate an even greater electrical force, so that even if some of the electric force is lost in the horizontal direction, it will be able to cancel the gravitational force using only the vertical components. We can see this with our calculated charges. The value of the magnitude of charge calculated in line of charge is a magnitude larger than it was for the point charge. This value is going to be more accurate than a point charge model because it accounts for how an object charge will distribute itself over its surface. We've now looked at two ways to determine the excess charge of an object and how the electric force interacts with each other. Thank you for listening. Goodbye.